So one kind of equation that is going to come up a lot in this chapter is equations with fractions. All right, and these can be kind of annoying if you don't know exactly what to do. All right, so what I want you to do is kind of recall all the things you learned about with fractions, not only in the last chapter that we did, chapter 16, but also just like from 7th grade, right? Where you want to get the same denominator on both sides of an equation, just so that you can more easily combine terms, right? So this is from your book. It says, more complicated fractional equations can be solved by writing all fractions with the lowest common denominator and then equating the numerators. All right, that's fine. We can do that. So it says solve for x. Okay, well, what's the lowest common denominator here of 4 and 3? That would be 12, right? So, okay, let's multiply this by 3, multiply this by 4. Remember, we have to do the same thing to top and bottom. So this becomes 6x plus 9, right? Because that's like parentheses, basically, over 12 equals x minus 2 times 4 is 4x minus 8 divided by 12. All right. Now, here's the thing, guys. If both sides of this equation are divided by 12, then I don't really need to write that. I don't really need to have that 12 there anymore. So what I can do is multiply by 12 on both sides, multiply by 12 on both sides. Those 12s all divide out to 1, and now I'm just left with the numerators that I had earlier. Plus 9 equals 4x minus 8. And now I can solve this equation, right? And if I get all the x's on one side, everything else on the other side, then I'm going to have x equals negative 17 over 2 or negative 8.5. All right. Example 2 says solve for x here. Got x over 3, 1 minus 2x over 6 equals negative 4. All right, let's start with this left side. Let's try to get both of these to have the same denominator. So I'm going to multiply this one by 2 over 2, fancy 1. So I'm going to have 2x over 6 minus 1 minus 2x over 6. I'm just going to go ahead and throw that in parentheses real quick. You'll see why in a second. Equals negative 4. Leave that negative 4 there, it's fine. So this becomes 2x minus 1 minus 2x over 6 equals negative 4. Now another thing I can do, without getting 4 to have a denominator of 6, is just multiply both sides by 6 right now. Right? And that 6 goes away, that 6, those divide out to 1. Negative 4 times 6 is negative 24. So I'm going to rewrite this here. I have 2x minus 1 minus 2x equals negative 24. Now, the key step here that some of you might forget is to distribute that negative. So that's 2x minus 1 plus 2x, right? Negative minus a negative is positive equals negative 24. So I'm going to have 4x minus 1 equals negative 24. Can't write today. Add 1 to both sides. 4x equals negative 23. Divide by 4. X equals negative 23 over 4. Or you could say 5.75, negative 5.75. Okay. Let's continue. This says solve for x. 3x plus 1 over x minus 1 equals negative 2. All right, let's not freak out here. One thing we can do always when we have different denominators is I can multiply that denominator by this denominator on both sides. X minus 1 times x minus 1. We know that x minus 1 divided by x minus 1 is 0. Or sorry, it's 1. It's 1, so we don't have to write it. So then 3x plus 1 here equals negative 2 times x minus 1. This is a lot more manageable already. So now I have 3x plus 1 equals negative 2x plus 2. All right, gather all the x's on one side, so add 2x to both sides, so 5x plus 1 equals 2. Subtract 1 from both sides to isolate the x, equals 1. Divide by 5, x equals 1 over 5, or 0.2. Nice. Okay, if the unknown appears as part of the denominator, okay, you can always use the LCD, the lowest common denominator method, or you can multiply by the denominator like I did here. There's a lot of different ways to do these. Some take more steps than others. Totally okay to do any of them as long as you show all your work.